Now we are going to see about the biasing of the PN junction diode. Basically, biasing means a PN junction diode connected to an external voltage source is called biased PN junction. What is the purpose of biasing the PN junction means? That is, we are going to control the width of the depletion layer. Thereby, we can control the resistance of the PN junction as well as the amount of the current that can pass through the device. Here we are having two ways of connecting the voltage source to a PN junction. First method is forward bias and second method is reverse bias. Forward biasing means positive terminal of the voltage source is connected to the P side and negative terminal is connected to the N side. So during the forward bias case, large amount of the current flows through the junction under this condition. Next, reverse bias. So reverse bias means positive terminal of the voltage source is connected to N side, negative terminal is connected to the P side. So in reverse bias condition, we don't have any current flow through the PN junction diode. Now we are going to discuss about the forward bias PN junction. So first, initially we should connect the voltage source to the PN junction. So in this voltage source, positive terminal is connected to the P region and negative terminal is connected to the N region. So which means your PN junction is forward bias. So the basic definition is when external DC voltage applied to the PN junction is in such a direction that it cancels the potential barrier. So here your potential barrier value decreases, thus permitting the current flow. It is called forward biasing. So by connecting the positive terminal to the P region, so here the poles are repelled by this positive terminal of the voltage source and they are forced to move towards the junction. Now the holes are moving towards the junction. Here as well as in N region, the electrons are repelled by the negative terminal of the voltage source. So and they are moved towards the junction. So because of this acquired energy from the voltage source, some of the holes and electrons enter the depletion region and they recombine themselves. So this reduces the depletion region width. So the barrier potential reduces with the forward bias case. So more magnetic carriers diffuse across the junction. So large current to flow through the PN junction. So for each combination of free electrons and the holes, an electron from N terminal, negative terminal of the voltage source enters the N region. So then it moves towards the junction. So similarly, P region is nearer to the positive terminal of the voltage source. So an electron breaks a covalent band in the crystal and enters the positive terminal of the voltage source. So thus for each electron which breaks its bond, a hole is created. So this hole drifts towards the junction. So the current through the external circuit is due to the movement of the electrons only. So current within the PN junction is nothing but the sum of the electron current as well as the hole current. The current in the external circuit continues to flow as long as the voltage source is present in the circuit. The current increases with increase in applied voltage. Here the current is in the range of milliampere. The maximum value of the current depends on the actual or bulk resistance of this semiconductor material. So as a summary of this, the applied forward potential establishes an electric field which acts as against the field due to the barrier potential. So the resultant field is weakened and the barrier height is reduced at the junction. So the potential barrier voltage is very small. A small forward voltage is sufficient to completely eliminate this barrier. So once the barrier potential is eliminated by the forward voltage, junction resistance becomes almost zero and a low resistance path is established for the entire circuit. So potential barrier is reduced and at some forward voltage, that is For germanium, it is 0.3 volt. For silicon, 0.7 volt. The junction offers the low resistance to the current flow. So the current flows in the circuit is due to the establishment of the low resistance path. So the magnitude of the current depends upon the applied forward voltage. So in the forward bias case, if the applied voltage increases, automatically your depletion work decreases. So the barrier potential also decreases, the resistance decreases, and your current value increases. Here the current flow is due to the majority carriers. So it is known as forward current. The flow of the minority carriers remains the same as in case of the diode with no applied voltage. The current contributed by the magnetic carriers is referred as reverse saturation current or reverse leakage current. So your reverse saturation current is in the range of nanoampere to microampere. The reverse saturation current is in opposite direction to that of the forward current. So reverse saturation current magnitude is negligible when compared to your forward current. The PN junction does not permit the current to flow until the external bias voltage overcomes the barrier potential. When your applied voltage is less than your barrier potential, means at that time current does not flow through the PN junction. When your applied voltage exceeds the barrier potential, automatically current will flow through your circuit. Next, we are going to see about the reverse bias PN junction. So, reverse bias PN junction means when the external DC voltage applied to the PN junction is in such a direction that the potential barrier is increased. It is called reverse biasing. So, we should connect the voltage source to the PN junction. Positive terminal of the voltage source is connected to the N region. Negative terminal is connected to the P region. So now the holes in the P region are attracted towards the negative terminal of the voltage source, and electrons in the N region are attracted to the positive terminal of the voltage source. So now the majority carriers are drawn away from the junction. So as a result of this, your depletion layer with increases, so your barrier potential is also increased. So increased barrier potential is difficult for the majority carriers to diffuse across the junction. So no current due to the majority carriers in the reverse bias PN junction. So your junction offers now very high resistance. So the barrier potential helps the minority carriers in crossing the junction. So as soon as the minority carriers is generated, it is drifted across the junction because of the barrier potential. So small amount of the current does flow through the reverse bias PN junction. So the amount of the small current depends upon the number of the minority carriers diffusing across the junction. So which also once again depends on the generation of the minority carriers within the P region and N region. So the generation of the minority carriers depends on the temperature and which is independent of the applied reverse voltage. The current due to the flow of the minority carriers remains same whether the applied voltage is increased or decreased. So this current is known as reverse saturation current. As a summary of the reverse bias condition, applied reverse voltage establishes an electric field which acts in the same direction as the field due to the potential barrier. So resultant field at the junction is strengthened and the barrier height is increased. So the increased potential prevents the flow of the charge carriers across the junction. So a high resistance path is established for the entire circuit and hence the current does not flow. So the potential barrier is increased, junction offers the very high resistance to the current flow. So no current flows in the circuit due to the establishment of the high resistance path. So in reverse bias case, your voltage increases, your depletion width increases, barrier potential increases, your resistance value increases, and hence your current value decreases. So in reverse bias case, a small amount of the current will flow due to the diffusion of the minority carriers across the junction. So this minority carrier is due to the thermal energy, that is whole electron pairs are generated throughout the semiconductor material. So hence the current is produced. That current is known as reverse saturation current. So as a summary of the biasing in the PN junction diode, so during the forward bias case, if the supply voltage increases, your depletion would decreases, so barrier potential decreases, resistance decreases, current increases. During the reverse bias case, if the supply voltage increases, depletion width increases, barrier potential increases, resistance increases, your current decreases.